We could have, in the near future, effectively robots on the ocean floor, roaming the ocean floor. It's all in the name of surveillance. So it's about on the ocean surface, I say. Let's get more on this from our next guest, Ruth Patterson. Talk us through what we're talking. I said floor, it's the ocean surface. What are ocean robots going to do in terms of surveillance of the with self-driving, they're called, in terms of surveillance of the world?
Yeah, so we have just had a global network of these surface robots endorsed by UNESCO. And the purpose of this network is to have better coverage of the ocean for weather monitoring. And so the data is set to go all the way up to the global Earth system models that reside within mostly Europe and the US, but also Australia, and improve weather forecasting for our really remote locations and regions like the Northern Territory.
So about forecasting, security awareness as well, and I suppose some of these areas, I mean, it's staggering when I guess for most of us, when you fly over some of the world's oceans, just how much ocean there is out there compared to land. How much out there is just rarely seen or mapped properly before this sort of self-driving data collecting robot ability?
Yeah, absolutely. There is. So under the Global Ocean Observing System, we have several different types of networks, and they're different types of platforms that are distributed around the globe to try and increase coverage. And just this year, after 4 years of campaigning to be recognised to have these surface vessels recognised as scientific data collection for weather and climate monitoring, we've been able to receive this endorsement and pinpoint areas and also severe, like places where it's really difficult to monitor the ocean. We can send these ones in because we can actually drive them into locations and drive them into storms and tropical cyclones and hurricanes and have them operating in areas that you just wouldn't put ships with people on board.
Yeah, well, I guess in particular when you talk about hurricanes. The other element, I suppose, when you mention monitoring climate, a big part, isn't it, is ocean, whether it be temperatures, but other measurements as well as to different effects that any change in temperatures are having, and a lot of those around tidal patterns as well that could actually make some parts warmer but some parts a lot cooler.
Absolutely, and I think what's been really widely accepted and built up for this capability, like the big expectations of them, is that these particular platforms can monitor a range of different variables aside from just the basics. Because they're quite large and they're renewably powered, we can have 28 different variables being collected. So that might be things like ocean salinity, ocean temperature, air temperature, wind, like all the things that you would see on a weather station, and out there collecting all of these types of data all at once. And so what we can get out of that is this really incredible coverage of how the ocean and the air interact with each other. And that's one of the big, great unknowns when we start doing forecasting and modelling, is how the ocean and the atmosphere interact. So that's a big part of this new capability, is improving our ability to take those really fine-scale measurements across really, really large areas across the global ocean.
Not to mention storm watches. We've got dramatic pictures here. I imagine you get people just wanting to have a look at how incredibly dramatic some of those pictures would be during a storm at sea.
Absolutely. And so that footage is actually from the sail drone, which is one of our USVs in our network that operates in the US. And they operate out of NOAA, the Pacific Marine Environmental Laboratory, and that particular that particular footage comes from a sail drone that's managed by Greg Foltz and Lev Looney at the Miami Hurricane Center. And so this footage is a world first, seeing inside the eye of a hurricane, and that's only really possible because of this new technology. So yeah, it's actually interesting. These observations, the scientific observations that were made with this sail drone were also incorporated underwater gliders and aerial deployments from the hurricane hunters and things like that. So there's quite a lot that goes into coordinating the deployment of all of these different types of platforms to give us all a big picture of how these systems really work.
Yeah, I'm sure a lot of fascinating insights will follow as well. Dr. Ruth Patterson, appreciate your time today. Thank you.